So we're looking at this as the question we stopped at yesterday. You guys be excited to know I checked YouTube. I'm up to 12 views. Feeling pretty good. Wow. Be interesting to see. And the question I have to ask myself is, why did I not do this in the past? And then I would have a bank of exams with explanations. Yeah.
But you said no.
Yeah. But then there's only so many more years left in my career.
I just always said that.
I got a couple more. Couple more. Okay. Let's take a look at question number 20. I always get nervous when they ask for false. I don't know why. I just don't like it. But which one of the following statements is actually false? So we're going to go through this. Does this graph have only one x-intercept? I'm not really even sure what's going on with this graph right now. How would we test to see if it has one x-intercept? Like, what should we do? Okay. Even honestly, before we would do that, what could we do?
At the top, then see if the top has. Well,
Oh, okay. So you guys are actually saying some wonderful things. We know that if we're looking for x-intercept, right, we're trying to figure out what is true when y is equal to 0. And where do we find x-intercepts in a rational function?
in the top.
In the top. And then nothing canceled. So it looks to me then, if you set the top equal to 0, you get 8x squared is equal to 0. There's nothing wrong with that. So it's going to be at 0. So this actually passes through the origin if you wanted to sketch it. We don't have to sketch it. I just factored it. Does this function have a hole or a discontinuity in it? No. So wait a second. That means it's telling us that it does have a point of discontinuity. So is this the false statement? That's why I don't like false. So the correct answer for this is letter B, right? This function does not have a hole.
Oh, yes.
Yeah, I always hate false. I always struggle with it, but we just have to find the one thing that's not true. Should we continue with letters C and D?
If you want.
If you have time, maybe if you come back, but right now, don't be afraid to just move on. Okay, next. Can we find the equivalent form of the following? I think what they're asking you to do here is just to recognize that this is log to the base a of x to the -2 when we enjoy the fact that this exponent can be written in a negative manner. And then I look across, it's not there yet, but then if we apply the power rule to our logarithm, I think now then we look a little bit closer. Is it close to C that the correct answer is, be careful, it has to be letter, nope. No. I think I had one too many donuts this morning. It's letter A. Okay. Are we okay with that? But you can see how easy it is to make a mistake, right? And kind of the last thing I want you to do is racing through the exam. You guys have 3.5 hours. Take your time, enjoy the experience.
When do you think we'll have the exam?
Truthfully, most students well prepared have checked, done 2.5 hours.
But done and checked.
Done and checked in
Just
2.5.
done by-
Do you have like a lunch date or something?
No, I'm just wondering.
Okay, 2.5 hours is about right. I had this question earlier. Someone asked me a version of this. If you have 13, choose 6. How do you find the one that's the same? You can guess and check, but there's another way. There is another way. I can tell you what it is. I've done it too long. It's going to be, take a look at 13, look at 6, find the difference. So it's going to be 13, choose. Wow. I apologize. It's 13, choose 7. I just looked at the difference between 13 and 6. Now, if you're not convinced, you could test it yourself. This would be 13 factorial over the difference between 13 and 6 factorial, 6 factorial. And then the other one is 13 factorial over the difference between 13 and 7 factorial, 7 factorial. I'm not going to go much further, but can you see this one is 7 factorial, 6 factorial on the bottom. The other one is 6 factorial, 7 factorial. Does that help you? Okay, so really I'm just looking at the difference between the n, the total number of objects, and r, the number of objects to be selected. Or yeah. And then right away you can throw out like A and C are out. So the correct answer has to be letter B. Okay. All right. Moving on to the next. Okay, we're looking at the difference between two functions. We're supposed to identify the correct one. They're just asking us to do some algebra. Be careful. So x plus 5 is the first function, and then you're going to subtract the second function. Please understand that you're subtracting the entire function. So make sure you have this minus sign subtracting the entire function. And then when you clean this up, it should clean up pretty quickly, we hope. Is it minus 3x plus 9?
Five minus one.
Oh my God. Yeah, so it's plus 4. Wow. Okay. So it's letter B. Thank you. So it's also very important that you don't eat 2 donuts right before you write the pre-cal exam. Yeah, that's right. That's right. If you want to earn a shirt, yeah. I don't know what's going on. It's weird. Like yesterday, I felt pretty spot on. Yesterday, I was moving pretty good. Today, it's like not so much. Okay. They're doing a transformation now. They're telling you the type of function. It's a radical function. So I'm going to remind you of your father of all radical functions. So this is 0, 0, 1, 1, 4, 2. So that is y equals the square root of x. That is the father of all radical functions. Okay. And then the really nice thing about this particular function is when you're doing the shifts, you never have to worry about it. You don't have to worry about the stretches. So it's pretty clear that we went 4 steps to the left. Is that true? And then we followed that down with 2 down. So I've got the 2 shifts are done. I do have one problem though. There's definitely a change. And you could describe it either way. It's up to you. And I think when I did this particular version, normally this function should go up 1 over 1, correct? And it's supposed to go up 4 over 2. That would be the normal function before we decide to distort it with a stretch. So how do you want to reorganize this? It's kind of up to you. It seems to me that we've got this dot here. If we think about it horizontally, it was once 4 steps away. Now it's only 1 step away. What do you multiply 4 by to get 1? 1/4. Are we okay with that? So can we say in this case here, there is a horizontal stretch, a change horizontally by a factor, careful with this, by a factor of 4. Okay, so then when we describe this function, you're going to say, well, I guess it's the square root of, so that's a good start. If we want to create a horizontal stretch by a factor of 4, so that's a change to the x coordinate, what do we actually multiply by? 1/4. And then now you got to be more careful. So it's 1/4 bracket x. Was there a shift horizontally 4 steps to the left? So then you better write plus 4 in bracket. Was there a change vertically? Minus 2. I know what the other version is because I can kind of see it. The other version would be y equals. You could take a look at that 1/4 that's inside. If you brought the 1/4 outside, can you see this is now 1/2 multiplied by, inside would still be the same, x plus 4, and then outside is minus 2. I hope you can appreciate that these two concepts are equivalents. That is another way you could organize it. It's up to you. Both are acceptable. I think we talked about this before. At least I hope we have. Like, do we appreciate that if you have y is equal to the square root of 9x, that's the same as saying y is equal to 3 square roots of x? Are they not the same person? Okay. All right. Be careful with that. Be careful with your horizontal changes. Next. Does it ask for the domain? Then I don't think you need to state it. The truth is, like, you could see the domain from the function. If you wanted to state the domain where, like x has to be greater than or equal to minus 4, that's fine. but I don't think you earn any marks for it. And then the trouble is if you state the domain and you state the domain wrong, you could lose marks. Okay. All right. We're gonna run into a question in the future, and it's one of the questions you actually asked me about, Jovi, where you're putting two functions together, like maybe you're adding them, maybe you're subtracting them, maybe you're making a composition. And there you have to clearly state the domain because both functions do not have the same. That's different. And there's a great question that's coming up for that, okay? And it's one where lots of people lost marks on it. Okay, we've seen versions of this. At least I hope we've seen it on our tests and on our quizzes. I hate secants. You can still say that. It's okay. I hate secants. So if we hate secant, we're going to rewrite it as the cosine. Oh, careful, though. If it's okay with you, I'm probably going to cheat. I'm just going to write over here. What is the cosine of 2 pi by 3? Wow, they're all coming at us right now. 3 pi by 3. Isn't it minus 1/2? Yeah. All right. Maybe let's look at our unit circles a little bit. So if that's the case, then what's the secant of 2 pi by 3? -2. Okay. What's the sine of minus 5 pi by 3? If it's okay with you, I'm probably going to think of it as sine of minus 10 pi by 6 because I count by pi by 6 is better. And if I'm in minus 10 pi by 6s, am I not at like positive pi by 3? And at that point, then I'm going to tell you it's positive root 3 over 2. And again, this is when, if you filled out that unit circle that they give you, this will make your life easier. And this is one of the weird times they've done this. You're actually solving for x, and it's equal to 3. So they've just added another layer in. Okay. All right, let's do a little bit of algebra. Don't we just end up creating minus the square root 3 of x is equal to 3. So x itself is equal to minus 3 divided by the square root of 3. And then I'm like, are we allowed to leave it as a radical in the bottom? You probably are, but I'm so trained to never do that. So when I rationalize my bad decision, I end up with minus 3 square roots of 3, all divided by 3. Is it safe to say our final answer is minus the square root of 3? I think so. Okay. I'm going to double check right now if they cared if you rationalized it or not. Truth be told, they would have accepted this. So there's a couple times now people have asked this. So if you don't need to rationalize, should you bother? I'm looking at it right here. I have the answer key that they provided us. They said they would accept either version. So they said they would accept this version that I've highlighted in green, and they would accept this version here. So the math person in me is like, well, I'm going to stop as soon as I've earned all the marks. Well, they should say it, and they don't say it in the question. All the question says is, can you generate the exact value? Huh?
Do they usually ask?
I just think I was taught that way, so I just instinctively want to do it every time. I gotta admit, like in the calculus textbook that you guys will see next year, they don't rationalize. Okay. All right, next. So you've got a sketch. I think for this type of thing, the best thing for you to do is, what's the parent function in 26? Perfect. So go to the side, just set it up, y equals 2 to the power of x. Now, there's a few ways you could organize this too, so you don't always have to do it the ways that I tell you. Remember, you get to choose values of x. The function chooses values for y. Let's just pick a few, but not too many. Let's go like -2, -1, 0, 1, and 2. And this is definitely a question you probably want to take your time on when you write the exam. I know there's a way you could do this a lot faster, but we'll just move forward. Okay, do we understand that if you do 2 to the -2, is that not 1/4? Are we okay with that? 2 to the -1 is 1/2. 2 to the power of 0 is 1. 2 to the power of 2 is 2. And 2 to the power of 2 is 4. Okay, that's the parent function. What are the transformations of this particular function? What changes are going to be made? Yeah, I like that. So we're gonna take every single x value, and according to our information, we're gonna do a reflection. So we're just gonna do the opposite of every x value. So just think of that minus sign as the opposite. And then are there any changes to the y values? Yeah, aren't we shifting this lovely function down 3? So it's gonna be y subtract 3. So just going to do the opposite of the x's. So I can do that. So the opposites, so it's now positive 2, positive 1. You can't take the opposite of 0, negative 1, negative 2. And now we're going to have to do a little bit of math. We're going to have to take like 1/4 subtract 3, 1/2 subtract 3, 1 subtract 3, 2 subtract 3, 4 subtract 3. And again, just take your time. You guys have 3.5 hours for this. When we did this in class, I said to you, don't think of it as 1/4 minus 3. Think of it as minus 3 plus a quarter. What's minus 3 plus a quarter? Perfect. So Avery's got it. It's minus 2 3/4. So it's slightly above minus 3. And then this one is also slightly above minus 3, but it's slightly more above. So it's going to be minus 2 1/2. Then it's minus 2, then it's minus 1, and then it's 1. Okay. I did say to you that when you draw, be it exponential or logarithmic, before you do anything, you should draw what? The asymptote. And Elizabeth, what is the asymptote? Is it horizontal or vertical? Horizontal, lovely. So we need to know that coming in, that we're going to have a horizontal asymptote at minus 3, and that will help us to figure out where these go. And when you do the provincial exam, the expectation is that you're going to label and show this asymptote, label it as a horizontal asymptote, label it as y is equal to minus 3. Okay. Now we can have some fun. We actually said that you only really need 2 dots. If you read that earlier, did I do something wrong in here? Good question. I don't think so. Let me double check. I don't think you need arrowheads on an asymptote. Okay. But we do need arrowheads on the function. Okay, let's plot some points then. We know that when x is 2, this function is actually minus 2 3/4. So do the best that you can. It doesn't have to be perfect. So you're relatively close to the asymptote. At 1, you're a little bit more above the asymptote. 0 minus 2 is a critical point, right? That's an intercept. Yeah. I don't think so. Especially too, if you've got the table of values there. And I got a nice heavy dot here. And they've given us the scale too. Like, see how they put the 1 and the minus 1? They've given us the scale. So we're abiding by the scale given. Minus 1, minus 1. And then, of course, minus 2, positive 1. So in terms of detail, we've actually given them far more than they probably need. I think in their mind's eye, like if you just given 2 dots in the horizontal asymptote, you'd be okay. Make sure you get the general shape. So this is a exponential function that's experiencing decay because it's getting smaller and smaller and smaller and smaller. Make sure you have your arrowheads. Make sure you get close to the red line, but do not cross the red line. Right? We understand that this function has to careen. Okay. I'm just going to double check what you said. Like, should you label points that are here? I don't think so because they forced us the scale. So I think you're okay, Arden. Yeah, so it's funny because when you take a look at this function here, if you truly rewrote it, isn't this just y equals 1 over 2 to the positive x minus 3? Can you see that's what it's asking?
Right. So like,
that's why it's decaying. That's right. But we can do it by transformation if you're more comfortable, whatever works better for you. Okay. All right, there's 26. All right, so I get mad at them every year when they do this. Do we know this? Because I always say this is not a grade 12 concept, but I'm glad that we're looking at it. You guys learned this in grade 11. Yeah, this is a reciprocal function. And for whatever reason, I don't know who it is on the committee, but they've had a reciprocal function question like 3 or 4 years in a row, despite me complaining because they don't really listen to me when I complain. Okay. All right.
We didn't learn about this in class.
You didn't learn about it in grade 12, but you do it in grade 11. So let's talk about what it's asking us to do. It's asking us to do reciprocals. So I'm just going to help you along here. Let's do this piece. First things first. So we understand they're asking us to consider 1 over the function. So let's remind you, what's the reciprocal of plus 1?
1.
1. Okay, I'll make it easier. What's the reciprocal of 2?
What's
1/2.
Okay.
Okay, you ready? When you multiply reciprocals together,
Yeah.
you create 1.
Like the reciprocal of 1 is 1.
Right. And the reciprocal of 3 is 1/3. Because when you multiply them together, what do you get? What's the reciprocal of 1/10? 10. Because when you multiply them together, you get. So reciprocal by definition is when you multiply them together, you get 1. Inverse is the undoing of what the other function's attempting to do. Yeah, kind of, but opposites, when you add opposites together, you get 0. You're gonna have dreams on the weekend. The concepts are close sometimes, right?
Yeah.
But inverse is the undoing of what the other function is attempting to do. And if the other function's complicated, there's many steps.
Logs undo.
There you go. Okay. All right. So here we go. This is what you're going to do. You're going to do the anchor points first. So you have an anchor point here because the function's value here is 1, and we know that the reciprocal of 1 is 1. We're also going to do the other anchor point because what's the reciprocal of -1? -1. Those are your anchor points. Then let's focus our energy on this stretch right here. Can you see that the y values are getting larger? So the reciprocals then must be getting smaller. So if it helps you, if we look at this moment right here, this is actually 2. So what's the reciprocal of 2? 1/2. The next dot up here is actually 3. So what's the reciprocal of 3? 1/3. And then the next one is 4, 1/4. Can you see that this is going to get smaller and smaller and smaller as we go to the left? Those of you that suffered with me in first semester, we discovered the fun zone or the blue zone. The blue zone is in here in terms of the y values. Oh, wait. Can I put something else in? What happens when you take the reciprocal of 0? Can you see that if you put 0 here and you try to take 1 over 0, so what happens here at the 0? You try to, not a POD, a vertical asymptote. So we're going to, I know I changed the color and I'm sorry about the colors, but you get a vertical asymptote where the original function is equal to 0. So there's your vertical asymptote. They're easy to find whenever working with reciprocal. And you know you're working with the reciprocal because it's saying 1 over your original function. And you can see why having 0 is a problem. I just focus on this. Okay. I understand you have great questions. Can you make sure you say x is equal to -2 and indicate that's a vertical asymptote? Okay. Now can we talk about the blue zone? But you guys kind of already know what's going to happen in the blue zone because this is not your first experience with an asymptote. So if I pick a value in here, I say to you, this is 2. What's the reciprocal of, sorry, I'll try that again. Isn't the y value here like 1/2? So we're in this little zone here between 1 and 0. What's the reciprocal of 1/2? 2. What's the reciprocal of 1/3? 3. What's the reciprocal of 1/5? 5. And in fact, aren't we kind of expecting this behavior? We in fact end up with, if it's okay with you, don't we get an arm from a rational function? Should look something like that. I know I've kind of missed my anchor point. I just make my anchor point bigger. Okay. That's what that particular arm looks like. In fact, then I think what we should do is, should we indicate the other asymptotes? Do we know what the other asymptote is? Yeah, you've got a horizontal asymptote here. Horizontal asymptote y is equal to 0. Well, put the dots so they know. I would put the dots. Put the dashed line. Okay. Now we're going to get to the other side here. I think we're pretty good about what's going to happen in the fun zone. So this is the fun zone between 0 and -1. So here, if you have -1/2, the reciprocal is -2. If you have -1/3, the reciprocal is -3. So I think we've had this experience before. We know what functions look like when they start to careen, when we have an asymptote in play. Now that I look at this really closely, some fun things are going to happen when we draw the remaining piece. Can you see that this is where the original function here happens to be -2? What's the reciprocal of -2? -1/2. So this is -1/2, this is -1/2, this is -1/2, this is -1/2, and this is -1/2. Can you see it never changes? No, it won't careen. So you could just rewrite it like this. And it's twofold. So it's going to be a horizontal line. And then here's another piece, because some people did this too. Should we have an arrowhead on that section? No. Can you see that the original function terminates there? So this is a nasty question. 3 marks. No, I'm okay with the 3 marks. I'm okay with 3. So if you make a mistake, it's not too costly. Yeah. So, first things first, if you take a look here, like you can see this arrowhead is here, and that's what's going to force us to keep going in this direction here. Now, why is there an arrowhead here? Because aren't we going all the way to 0? Are we not approaching 0? So that forces this will actually race away towards positive infinity, so it justifies an arrowhead there. This function here does go all the way to 0, so that forces the arrowhead here because it is going to race away to -infinity. But here, this function stops. Okay. All right. Next question. And then just for reference, don't do all your work on the top one, or do whatever you want. Try and do all your work on the bottom one. We'll still mark it. Yeah. Okay. Tan pi by 12. You guys need to remember the formula it's given to you. I think it's the tan. I'm going to do it this way of a minus b. That is the tan of a minus the tan of b all over 1 plus tan of a tan of b. You are given this. Then you need to recognize that pi by 12 is the equivalent of pi by 3 minus pi by 4. If it helps, remember pi by 12 is 15 degrees, isn't it? And pi by 3 is 60 degrees. And pi by 4 is 45 degrees. Can you see where that came from? So then you're going to rewrite it as the tan, and then you're going to put in our angles. So pi by 3 take away pi by 4. And then just substitute. Okay. And then you need to remember, how does tan work? A little bit on the unit circle. Can I remind you of this here, just to help you out? If you're at pi by 6, that's delayed. If you're at pi by 6, isn't the tan of pi by 6 the flat one? So it's 1 over the square root of 3. Uh, and then 10 pi by 4 is where the horizontal component and the vertical component are the same, so it's equal to 1. And then the 10, why do I feel like I owe you money? The 10 of pi by 3 is the steep one, so it's √3/1. Yes, Mr. Solomon, how may I help you today, sir?
National Biology Competition,
Oh,
University
wow.
of Toronto.
Wow.
I'd like to present Katie Wolkenstein, a certificate participation. I gotta be back, because I didn't know you were here. I got another one. So I can repeat the performance in about 6 minutes.
Okay.
Continue.
So can we remember that then? Like this is the steeper one, so it's √3/1. This is the favorite one because it's just 1/1. And then this one here is the flat one, so it's 1/√3. Does that help you in terms of your values for tangent? In terms of the exact values on the unit circle? When you travel back over here, then you can start putting the values in. So tan of pi by 3 is just √3/1. Minus, I'm just going to write this as 1/1. I don't know why I just did that. And then downstairs, it's 1 plus 10 of pi by 3 is still √3/1 multiplied by 1/1. And I'm actually surprised how little you have to do after this, right? So upstairs, isn't upstairs just √3 minus 1? And isn't downstairs just 1 plus the square root of 3? And you don't have to rationalize it. So just leave it. Just leave it. Move on with your life. Okay. No need to rationalize those bad decisions. Okay. All right. Moving on. This looks strangely familiar.
This was on our test last
It
night.
was. It was. And then it says what? So I feel like. I know there was a lot. I don't know. There was a lot of feelings in this exam. I feel like in order to have a vertical asymptote, the denominator must be equal to 0. X squared plus 4 never equals 0. Therefore, no vertical asymptote. Are we okay with that? If I don't write that? Okay, let's move on. This is classic. This is friendly. This is warm. I like this one a lot. They are when you know what you're doing. So you're going to build one log, correct? And we're just using, as you can see, if you have two logs being added together, it turns into one log where the arguments are multiplying, and all of which is equal to 2. And then you're going to remember if you're solving for x that's trapped inside of the logarithm, your best bet here is to unravel the logarithm. So you get 3 to the power of 2 is equal to, this is going to be x squared plus 8x. Now you're just going to end up with 0 is equal to x squared plus 8x minus 9. Pray that it factors, and I'm pretty sure it does. Especially too, because it's in the non-calculator section. Yeah, I know I was talking to Aislinn, like sometimes there is one question early on in one exam where it doesn't look like it factors, and it doesn't, and you have to use the quadratic formula. They're more likely to ask you to do that in the calculator section. All right, when you factor this, it should factor into x plus 9 times x minus 1. You discover you've got 2 candidates for solutions. One of them works, probably one of them doesn't. I'm already looking at it. It looks to me like minus 9 is out, plus 1 is in. Can you please make sure you indicate which one is in and which one is out? Just put an X and a tick. Don't make it any longer than that. I would use a pencil on the exam. I know I have some students that want to use pen. Please don't.
Is there anything?
No, you just bring some pencils. And you don't need to bring, like, you could bring a clicky pencil.
Bring a pen to like.
Oh, you can bring like a regular, like.
Yeah, you can bring a clicky pencil. What do we actually call these? They're not called
Mechanical.
mechanical pencils.
Can you also bring a pen?
If you want to bring pens with you, you can. Like, I don't mind. Sure. Sure.
Yeah.
Sure. I don't think it says anywhere that you need to absolutely use a pencil. It's just, it's easier. Oh. All right, ladies and gentlemen, we have another guest back in the house.
Is this appropriate then?
Sure.
All right, the Faculty of Science, Department of Chemistry. Elected for. Provide a certificate of participation for the 2024 recipient, Melina Palatgard. With a 1013 use exam, placed first in Shasbury High School.
Woo!
Wow. Out of one participant.
That's how we roll. Nice.
And the certificate of distinction going to AJ, who's not in this class.
No,
You guys-
next door, next door.
All right, sorry for the
Yeah,
disruption.
no worries. Okay, so this is the one that we always have the war with when we're marking this. So can we make sure that we do this correctly? We're gonna do it the Harley way. We're gonna do it the Harley way. So first things first, I always read this wrong. When they say at least one period means a minimum of one period. So guess how many periods we're gonna draw? One. That's what that means. At least just means minimum. You can draw more, but you can't draw less. Okay. Next, you're going to recognize, and let's do the labels. What are we supposed to do when you do it my way? Now you got a lot of room on the page. You could just ignore the graph, right? Yeah, you could do your own graph. Just because they give you one doesn't mean you have to use it. Okay. All right. If we're going to do it like this, can we be very clear that the average value is -1, correct?
Yeah.
So if you're going to do it this way, you have to say that, you ready? When you guys do the exam, can you do the following really clearly? Because we have arguments, I usually win. Can you just cross out the X and cross out the Y? Just put dots through them, whatever you want. Just cross them out so it's obvious that that's no longer X, it's no longer Y. Then can you call the average Y equals -1? Because that's the average, right? What's the amplitude of this function? Right. No, it is not. Yeah, if you're looking for amplitude, isn't it based on the number in front of the function? So your amplitude is 1, so be clear. Go up nice and high and then go up nice and low. But when you label these, when you go -1, up 1, aren't you now at 0? And if you go -1, down 1, are you not now at -2? Are we clear? Next, where or what is the period of this function? And they made it awkward. We have to do it in terms of degrees because of the nature of the shift. So you're going to do 300, yeah, 360 divided by 3. So that's not the worst thing. What is 360 divided by 3? 120 degrees. Okay. All right. Next, what is the start line of this function? So you will go down here and you really clear say X equals -30 degrees. Then you're going to remind the marker that the period of this function is how much? 120. And you'll just indicate it like this. This is the period of the function. But then you go back to the graph and you're going to put a ticky anywhere you like. And what value will that ticky be? No, 90. Because if you take 120 and you add it to our start line of -30, isn't this going to be 90 degrees? And now we just do the quarter points, right? So you just put the tickies in. So half goes halfway and then the quarter points. And if you want to, you don't have to do a ton of quarter points, but we'll just do a few. What's half of? Now, got to be careful though. I almost made the mistake. You're supposed to now take 120 degrees, and if you're doing the quarter points, don't we have to divide that by 4? And what's 120 divided by 4? 30 degrees. Now you can label what's minus 30 plus 30? 0. What's 0 plus 30? What's 30 plus 30? Can you see how beautiful this looks now? All right. Is it a sine curve or a cosine curve? Sine is the good one because it starts on the average. It reaches its maximum. It returns to the average. It hits rock bottom, and then it returns to the average. Can you make sure, too, your concavity is right? So concave, like a parabola facing down, followed, and then it switches to now a parabola facing up. And if you want to put a couple little dots here to suggest it keeps moving forward, that's fine too. See, and that's interesting, right? Because you could. I don't know why they get the distinction, because you're right. It does imply that it keeps going. It's up to you. So I might do this just so I satisfy all of the markers. A couple little extra dots. We know this pattern continues. Do you like that? There's our happy compromise. Yeah. Well, we don't need the domain. It's not restricting the domain.
I really never had.
Don't need it. Good question, but we don't need it. Next. Oh, I like this. One mark. Make sure you guys look at the marks. They're looking for one thing. Why must x be greater than 3? So how are we going to, so why is it that the domain of this particular function has to be greater than 3? Okay, so I want you to say, oh, does it say explain? See, this is weird. I feel. Let me say argument. No, I feel like the argument of a logarithm must always be what? Positive. Good. That seems too mathy for me.
X. Sorry,
0 is neither.
So
there's positive and zeros in this thing, like, well, that's.
0 has no sign. It has no value.
yes.
No, but you can have a negative log function. Think about what sketch a log function. If you went ahead and drew like y equals log x, you can get negative values for a log function. You just can't have a negative argument. Okay. Okay, moving on. There are no imaginary numbers in 40S pre-calculus, so let it go. All right. You ready? I got this one wrong. I know, it makes me sad. I should never get this one wrong. I missed the minus sign. Yeah. So what degree is this particular function for? So I don't know. Can we do the zeros first? But let's be careful of what the zeros are. So, and they're trying to help us. They're not trying to help us out. Don't we have a 0 at -1? But isn't that like the dreaded M2? By that, I mean the bounce. And then we've got a 0 at +3, but that's just a standard 0 at +3. And we also have a standard 0 at +5. So let's throw those zeros in right away. And then it's funny because I warn people, when you do these questions, what's going to save you isn't the x-intercepts, because you'll see them. It's the y-intercept, right? And when you look carefully at the y-intercept, all you do is you just grab all the pieces after you set x equal to 0, right? Because when you do the y-intercept, you set x equal to 0. And if you do this here, doesn't this turn into the minus sign that I missed, multiplied by, and then inside these brackets, it's just the -3. The next one, it's 1. Now be careful though, it's 1 squared, which isn't going to matter in this question, but if it was 2 squared, that would be a 4. And then multiply by -5. And be careful with this. I see 1, 2, 3 negative signs, so my end result will be negative. And I multiply the other pieces together. Can you see it's -15? So we're going to travel down, and I am not doing a ticky madness, so I'm just going to put 1 ticky, and I'm going to put -15 here. Okay. I'm going to remind you of where the bounce is. And this is a degree. What degree is it? 4. And it's a negative degree 4. Yeah, so doesn't it start low and end low? Okay. There's some shenanigans. It's true. No. Here we go. So it's going to come in low. It's going to bounce. It's going to smash through the y-intercept. It's going to come back in here. Here, it's going to have to change sign, though, and then bounce or come straight through again. So something like that. That's what they're looking for. I know you asked me, like, how far up do you have to go? As long as you're positive for a stretch, you're good. Okay, and then I will gladly, or your calculus teacher in the future will gladly show you how you find that point. But we're not doing that yet. Okay, there's 33. Sine 2 theta. We love sine 2 theta. Why do we love sine 2 theta? There's only one substitution for sine 2 theta. I better get it right. Isn't it just 2 sine theta cos theta? Am I right? Okay, good. So it's just 2 sine theta cosine theta. So here's the good news. We already know that sine theta was given to us as -2/3. And someone said to you, if I give you one trig fraction, I've given you all of them. So what you're going to do, this is a good reminder, is you're going to draw a right triangle to remember this relationship. We just presume theta is here. And then we're going to remember that sine is grade 10. Right triangle, sine theta is opposite over hypotenuse. And the trouble for us is we need to find cosine theta. That means we got to find the adjacent side. So we're just going to do a little bit of Pythagoras. Yes. So it's going to be x squared plus 2 squared is equal to 3 squared. X squared is going to be equal to 9 minus 4. X itself is the square root of 5. Okay. Therefore, isn't cosine theta the square root of 5 divided by the hypotenuse of 3? And does it tell us which quadrant? And we're in quadrant where tan theta is happy and sine is negative. So do a little bit of analysis. You are definitely in quadrant 3. Do you remember that? The cast rule? Yeah. Okay, all right. So now we can say sine 2 theta is equal to 2 multiplied by -2/3 multiplied by minus, because we're in quadrant 3, square root of 5 over 3. And then you don't have to do too much here. It does say exact value. You don't really need many options anyways. You don't have your calculator with you. You're going to tell me it's going to be positive 4 square roots of 5, all of which over 9. Are we okay with that? 2 marks. Good. Oh. How are we going to prove they're coterminal?
Like, you add a -2 pi, and you keep on doing it, and then it's tricky.
Okay, so I'm not gonna lie. I think when I did it, I said, well, let's start off with like 5 pi by 8, and let's go backwards 2 pi. That's just what my brain thought. So I start off with 5 pi by 8, and if I go backwards 2 pi, wouldn't that be 16 pi by 8?
Yeah. I mean,
No. But if I was gonna like convert 2 pi into pi by 8, yeah. Okay. And what does that actually equal? Negative 11 pi by what? 8. Is that the same as what they're offering here? No. So can I then conclude that they're not coterminal? I don't like that. Isn't there a better way?
I mean, like,
If they're coterminal, what must be true about the difference between the two angles? Must be equal to 2 pi, right? Coterminal angles, if you subtract coterminal angles, the difference has to be 2 pi, or at least a multiple of 2 pi, right? I think actually honest is you're going to take, let's do it this way. Take 5 pi by 8 and then subtract the other angle, and then simply ask yourself, is it a multiple of 2 pi? And if we do this correctly, it's going to be 5 pi by 8. This is going to be plus 11 pi by 4. And then we're going to have to make a common denominator. I know how you guys love fractions. So 5 pi by 8 plus, just multiply top and bottom by 2, 22 pi by 8. And that's now 27 pi by 8. Is that a multiple of 2 pi? The multiples of 2 pi would be 16 pi by 8. Double that again, 32 pi by 8. Is it safe to say that 27 pi by 8 is not a multiple of 2 pi? Sure. Yeah. Yeah, you can do it, but you can do it by sort of like a directed guess and check. There's nothing wrong with that. I think that's what I did. And then my brain went, I don't like it. It's clumsy. And then I realized if I just look at the difference between two coterminal angles, it should be. All right, we're at 35. Are we almost done? Okay. What I'm going to do is this then. I realize sadly that we've only got one question remaining, or not one question, one class remaining. I will finish the remainder of this exam on Monday, and I will grab a collection of other notable questions to consider from any exam in the past. Well, because we got the barbecue and everything else that's happening today. So I think that's it for today. Sorry, Arn. You guys are welcome. Like, I know you guys got the barbecue lunch. I believe they are putting me in the dunk tank at the beginning of lunch. So if you want to get out there and get there early. I think I'm only available for the first like 15 minutes. Okay. All right. Take care. Yeah, I will. Yeah. Thank you.
Oh, please, no, like, I.
yeah.
We had to